So, hello and welcome to another video from sickmouse.co.uk, where you can find the whole of GCSE Maths explained on video, all for free. And you can find some super revision guides there. Okay, so when I say super, I mean like amazing, seriously. Like the whole GCSE explained in 18 pages and a bit. At A5. Anyway, this video is about probability tree diagrams, and tree diagrams basically look like this. They look like sideways trees, okay? These are, even in tree diagrams, they call these things branches. Can you see? So you've got two branches, and then you've got branches coming out of branches over here as well. You've got three branches, and then three more branches coming out of each of those. So they look like trees that are sideways, except for they don't have a bark in the middle, do they? Whatever you call it. And what are they used for? Basically, you're just trying to show all the possible things that can happen in your given situation. Like my given situation in the first example is the chance of winning chess or losing chess, and then playing a game of a pool and then winning that or losing that. Okay, so let's quickly go through that particular example. So I'm going to play chess first, and the chance of winning chess, abbreviated to WC, is 2/5. Okay, so I can either win chess or lose chess. Now notice it doesn't say lose chess, because sometimes you have to work on the assumptions that if you win chess, then the other option is lose chess, unless they tell you can draw as well. Okay, so the chance of winning chess is 2/5. That means automatically the chance of losing chess has to be 3/5, because the probability should add up to 1. Okay, so 2/5 plus 3/5 is 1, so that's fine. Okay, now remember, tree diagrams are supposed to show you all the different things that could happen. So I could win chess, then win pool, or win chess, then lose pool, or I could lose chess, then win pool, or lose chess and lose pool. Those are the four different things that could happen, given that I can only win or lose a game, okay? And I'm not allowed to draw a game, okay? So once I've won chess, what's the probability now of me winning pool or losing pool? Well, it says the chance of me winning pool is 1/4. That means the chance of me losing pool is 3/4. And the same is here, okay? Whether I win chess or lose chess, it doesn't affect my gameplay in this given situation, and so the chance of winning pool and losing pool is the same as over there, okay? Now in the real life, it might affect me. I might feel down after losing a game of chess, and it might affect the way I play pool, and it might change the probabilities. But in GCSE, we like to keep it really simple, okay? So just try to understand, and you should be fine in the exam. Okay, so that's the tree diagram, and so is this, as we said before. But one tiny thing I'd like to mention that's important is that this is a nicer way to draw tree diagrams than that, because it feels more connected. Okay, this is a bit disconnected, and some inexperienced students, okay, they tend to make more mistakes when drawing it like this. Okay, they kind of spread it out too much. It should feel like one tree. But then again, I'm drawing it like this because sometimes you see it in the exam like this. Sometimes they draw the tree diagram for you, and they draw it like this, and they just say fill in the numbers or whatever. Okay, so let's move on to our second example. We're going to draw a tree diagram. We've got 3 green marbles, 2 white marbles, and 1 blue marble in a bag, and we're going to blindly, without looking, pick a marble. Then, this is important, then without replacing it, I'm going to pick a second marble. Okay, so this is how it works. There's 3 different things that could happen. I could either pick a green, white, or blue. Okay, I've got 3 green marbles out of a total of 6 marbles. 3 plus 2 plus 1 is 6. Okay, so the chance of picking a green marble is 3 out of 6. The chance of picking a white marble is 2 out of 6. And the chance of picking a blue marble is 1 out of 6. Now, given that I pick a green marble, remember, probability tree diagrams show all the possible things that could happen. I could get green then green, then green then white, or maybe white then green. These are all the different things that can happen. You've got 9 different things that are possible altogether. Okay, now if I pick a green in the first pick, that means I've got only 2 greens left in the bag, 2 whites and 1 blue. Okay, so I've lost a green, and that also means if I've lost a green marble, it actually affects the overall total of marbles, of course. I've only got 5 marbles left. Okay, so that means the probability of getting a green here after I've picked a green is 2/5, because I've got 2 greens out of a total of 5 marbles. Okay, but the probability of getting a white or a blue does not change. If I pick a green first, okay? Because the number of marbles, number of white marbles, and number of blue marbles hasn't changed, okay? If I pick a green marble first. So that means the chance of picking a white marble after I picked a green is 2 out of 5. Okay? But be careful, that does not mean the chance of getting a green then a white. It's a slight difference. Independently, the chance of getting a green is that. Independently of that, say, you know that situations happen, but you pretend that this is an independent event now, and you say, let's start from the beginning, and the chance of me getting a white is 2/5, okay? But imagine you have to say, this happens, and then this happens. Remember, there's 9 different things that can happen. So, for one thing to happen, and then the other thing to happen, it gets more and more unlikely as you go along the tree, because you have to... There's 9 different things that can happen. The more things that can happen, the harder it is for any one of those things to happen individually. So what I'm trying to say is, for 2 things to happen together, okay, is to basically, you have to do that times that. Okay, so the probability of green then white is 3/6 times 2/5. The probability of green then green is 3/6 times 2/5. The same happens to be the same number. Probability of getting a green then a blue is 3/6 times 1/5. Let's just do another random one. What's the probability of getting a blue then a green? Is 1/6 times 3/5. So you have to multiply the fractions as you go along the tree to get the probability of the thing at the end, which is in this case blue then green is the probability of this root. Yeah. Okay. Well, by the way, you're looking at this. If you're looking at this 0, the chance of getting a blue then a blue is 0 because you do 1/6 times 0, and that should be totally right because it's impossible to get 2 marbles when there's only 1 marble. Okay. Now let's look at these details here. What's the probability of getting a green then a white? Green and then a white, which is this one here. So 3/6 times 2/5. Okay, 3/6 times 2/5, which is 60 out of 30. 3 times 2 is 6, 6 times 5 is 30. Okay, just in case you forgot how to multiply fractions. What's the probability of getting a green and a white? You might say, hang on, isn't that the same as that? That previous thing we just did, green then white. No, green then white means you have to get green and then a white in that order. Green and white doesn't tell you has to be in a particular order. You can get in any order. You could either get a green then a white or a white then a green. Both those things, green then white or white then green, have the same meaning as getting a green and a white. Okay, so there's 2 ways of fulfilling this. There's only one way of doing that. Okay, so let's look at the probability of getting a green and then a white first of all, which you just worked out is 6 out of 30. And the probability of getting a white then a green, is also 6 out of 30 because I have to do 2/6 times 3/5. Okay, so overall probability of getting a green and a white is 12 out of 30. That's 6 out of 30, that's a 6 out of 30. Together they make 12 out of 30. Because remember, there's 2 ways of doing this. So the more ways there are of doing something, the more chance you're going to win, or you get what you wanted, or this probability. Okay? Because if there's 9 things altogether and you can choose 2 of them, there's more chance of that happening than just having only one option of your thing happening. Okay. Now finally, let me quickly summarize that. The more ways there are of something happening, the more chance of those things happening, obviously. So that means you should add those probabilities. So if green and white means 2 different things that can possibly happen, then add those 2 possible things. Now finally, what's the probability of not getting 2 whites, or not getting both marbles being white? Okay, so that means I don't want a white then a white. That means I want everything else. I want green then green, or green then white, then green then blue, or white then green, or white then blue. Everything except for white then white. Okay, that's quite a lot of different things. That means there's a good chance of it happening as well. Okay, now remember, I said all probabilities have to add up to 1. Okay, so the chance of this happening, and then the chance of that happening, then the chance of that happening, and all these possible things things going through the whole tree. Okay, so the chances of green, green, and the chance of sorry, let me put it like this: the chance of green, then green, plus the chance of green plus y, then white, sorry, plus the chance of green, then blue, plus the chance of white, then green, plus the chance of white, then white, plus the chance of white, then blue, plus the chance of blue, then green, plus the chance of blue, then white, plus the chance of blue, then blue, all together is 1. Okay, now if I simply want to work out everything except for the probability of getting a white then white, that's really easy. Since all of those have to add up to 1, all I have to do is do 1, take away the chance of white then white. Gives me the answer of everything else. So the chance of getting white then white is 26 times 1/5, okay, which is 2 out of 30. So 1 take away 2 out of 30 is 28 out of 30, and that's probability tree diagrams explained.